Good afternoon. Congratulations, you made it to the last session of the IETF. So, welcome to LWIG in Montreal. Please note the note well still applies. Is there anyone who hasn't read the note well yet? No. So, some status updates since the last IETF. 8387 RFC 8387 was published in May. So, and 8352 was published in April. So we can pat on our backs. We have stuff moving forward. We adopted also 2 working group documents. So we had the 6LoWPAN virtual reassembly and also the LWIG security protocol comparison. So we have quite a packed agenda. We don't get paid to work overtime. So if we finish early, that's a bonus. We'll try to follow this agenda as much as possible. One quick note for presentation 3, I guess, Carson, we are not going to have any presentation on the virtual reassembly because the draft is more or less ready. We are looking for feedback, comments, reviews, and I guess, Rahul, you promised that you are implementing this in production code, so you will be giving some feedback on the list. All right, so I guess we can start with the first presentation. Carlos, are you in the room? Yes. I'll pass around the blue sheets. Please sign them. Rahul, you are the Jabber scribe. Francesca, you are taking the minutes. So we have note takers and Jabber scribe. I still don't see Carlos in the room. Well, in that case, we might start with the second presentation. Is that okay? So I forgot to mention Suresh couldn't make to the meeting because of family reasons, and we have Terry in the room, so we have a AD in case we run into any issues. Where is Rahul? Rahul, do you want to? No.
Hello. Yeah. Okay. So I've already presented this draft, the technical details of this draft more than 3 times, maybe 3 times before. So this time I'm going to only give the details about why we really want to see this work going forward, as in what our primary motivations are, and some of the updates that have happened in the context of this work, which might also relate to this, which has direct implications of this work, and give the implementation status, of course. So with regards to, to set the context, so we started working on this issue because when we try to see that when we try to use 802.15.4 networks, and if the node density, or if you're trying to play with less number of nodes, like for example 10, everything works okay. But the moment you try to scale, that's when all the problem begins. So this is one of the first problems that we had to solve to move any further. The typical use case that we had was we were using 802.15.4 in sub-gigahertz mode, and the node density was quite high. So it so happened that we had hundreds of nodes connecting on the same hop, and how to manage the neighbor cache entries was particularly challenging because of certain issues. So one of the primary issues that we faced was the neighbor cache entry size is very limited, and you have such a huge node density at a given hop. So what are the neighbor cache entries that a node should entertain? So the primary considerations are the neighbor cache entries, which have direct implications on the routing stability. So if the routes are stable, if the neighbor cache is stable, you have less churn in the network, you will have more stable network. So that was the primary agenda for this particular work. So it also results in reducing a lot of control over it, because if you have a neighbor cache entries churn, the nodes will keep on doing the neighbor NDP signaling or some other signaling to make sure that the neighbor cache entry is populated before the packets are actually sent, and this increases the control traffic very highly. And it directly has an impact on the PDR or the packet delivery rate. So this is the primary motivation to use, to work it out, to work out the 802.15.4 sub-gigahertz range network on a constrained, on constrained devices with uneven node densities. So the primary purpose of the draft, what does the draft do today? It tells you how do you manage the neighbor cache entries. There is a reservation-based policy that is explained in the draft, which says that if you have an authentication phase, if you have a routing phase where the network adjacencies are getting established, and then eventually you have a traffic flow, application traffic flow. So you have to deal with neighbor cache entries during all these phases, and which are the neighbor cache entries that a node should entertain. The draft also specifies NDP signaling, but it merely gives some guidelines. It is not about actually standardizing or making any changes to the protocol formats. It also talks about handling secure and unsecure entries. So before the authentication or during the pre-authentication phase, the unsecure neighbor cache entries have to be managed. Now, this is a problem that even 6TiSH is trying to solve. We are putting some guidelines in place for this particular issue. The implementation status, Contiki already has a basic neighbor cache, neighbor policy, neighbor management policy implementation, but there are many pitfalls. There are many, it's not an implementation which can be used in production today. The primary problem being that Contiki doesn't have a key management protocol as of now, and it doesn't have any handling of unsecure NCs. So that is something that we have built in our private implementation. We want to eventually bring it back to Contiki and make it available. So one of the things that we have been thinking is to make it as an open source library, which can be integrated with Riot, Contiki, LWIP in the future, for example. So this is so we have already started the work. So we already have a private implementation. Without this neighbor management policy, it was impossible for us to scale to that kind of network. So we also received some feedback on the Wyson mailing list regarding the same issue, that how do you handle this uneven node densities. So this is a problem that a lot of people are facing once they start scaling the network. Other work in IETF. So one of the things that the draft talks about is most of the guidelines given are in a very reactive policy. What it means is the neighbor cache entries are getting established, and then if the table is full, it gets a negative acknowledgement. But what happens? So what happens if the evicted neighbor keeps coming back? There is no way for the evicted neighbor to signal that in a message saying that, okay, I don't have any resource anymore. Please don't come back to me again. So this is something that this draft cannot have any control over, because it requires some changes to the protocol specification. And we believe that there is some work happening in this context, especially the draft from Michael Richardson's, which we feel, even though those drafts currently do not have any specific text in this particular context, we definitely think that those particular drafts or that particular information can be made use of even in this case to make it proactively react to the neighbor cache churn. That's all. We had a good review from Mohit. We will be changing, we'll be incorporating most of his comments, and we really seek more implementers' feedback. That's all. Happy to take any questions.
Mohit, no hat. So I already went through the document once, and I think this is very useful and relevant work. We have clearly adopted this as a working group document. Going forward, when you are doing the next revision, and I'll review the next revision as well, I think one thing to consider is that this is an informational document, so we are not defining any new protocols here. So just take that into consideration.
Yes. So we have a section in the draft which says that if you want to do proactive identification of resource crunch, then these are some of the elements that you would need. And we hope that in the future, some other specification, for example, the Michael Richardson's draft that I mentioned, that might be able to cover some of the protocol elements that we would require. So this work is is a collaborative work with INRIA and Yanzi network, and they also have faced a similar issue, and they are also tackling the same issue in their networks as well. Just wanted to highlight that point as well. That's all. Thank you.
Carlos, you were late.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP Usage Guidance in the Internet of Things. So first of all, let's take a look at the status of the document. Since the last IETF, we have updated the draft once, that's revision -03, and this last revision intends to incorporate the feedback that we received in the last IETF, and also we have completed a few details in some sections. So let's go through the updates in this last revision. So a first set of updates is in the section that focuses on ECN. So we have added some details here, and we have also reworded a little bit the section. So we now state that ECN can be incrementally deployed, and we provide a couple of pointers to useful documents in this area. One is RFC 7567, which provides guidance on usage of ECN, and RFC 8087, which discusses benefits in terms of throughput, delay, and so on of ECN. Also, we state that the number of TCP stacks supporting ECN is increasing. And then, because ECN allows applying congestion control measures earlier than otherwise, it helps decreasing packet losses and retries. So this is beneficial for constrained node networks in general, because it helps avoiding unnecessary retries, which means unnecessary consumption of energy or bandwidth resources. And also it can be useful in some particular scenarios, also for additional reasons, like, for example, when there is transactional traffic with small data size, and if small windows are being used, then it may be difficult or even impossible to get 3 duplicate acknowledgements. That means that a packet loss will translate into an RTO expiration, which will just add some latency. So using ECN may help also avoiding this additional latency, which might just slow down the transfer unnecessarily. So we have also added text in the security consideration section. We have, in particular, added text on the so-called shrew DOS attacks, whereby one or more sources generate packets to coincide with consecutive retry attempts of a victim node triggered by RTO expiration. So in constrained node networks, as mentioned before, small window sizes may be relatively frequent, and therefore we may have also relatively frequent RTO expirations. So it means that constrained nodes might appear as appealing victims of this kind of attack. So there are some described mitigation techniques in the literature. One is RTO randomization, in order to try confuse a little bit the attackers by using an unexpected pattern of retries for the moments of retries. And also another solution is blocking the attack by routers. For example, when there's incoming traffic with some pattern that might correlate with this kind of attack, then the router might just block the attack. Okay, we have also updated the annex. Recall, this is the section where we collect details on TCP implementations for constrained devices. First of all, we have added a few introductory notes, such as that the survey done in this section is limited to open source stacks. Then also we state that this is not intended to be all-encompassing. And on the other hand, we state that the information contained here is based on what is available as of the writing. We have also added a few notes throughout the section on the implementations that have not been recently updated. That happens with the TCP implementations of OpenBSN and TinyOS. And also we have been able to complete the TCP features section of this summary table that we are showing at every IETF. Basically, this is the details that are highlighted in red. And however, as explained on the mailing list, we have removed the row that provided or was intended for memory requirements in terms of data size, because it was getting difficult to obtain those numbers. Nevertheless, we have a couple of interesting additions in this update, which are highlighted in orange, that basically for Riot TCP implementation, we were fortunate enough that Simon Brummer, who's the main developer of the TCP implementation for Riot, made some measurements of both ROM and RAM consumption of his TCP implementation, and they are both included here. So for the RAM details, they're included in the table caption part, and in particular, we have that for that implementation, one TCP connection consumes around 2.5 kilobyte of RAM, and then for each additional connection, each one will consume 1.2 kilobyte in addition. So that's all with regard to the updates in this last revision. So for the next version of the draft, which would be 04, we plan to at least address a couple of editorial to-dos that are in sections 5.2 and 5.3. And actually, we believe that the document is starting to be quite complete, and we would consider to possibly request a presentation of 04, both here in LWIG and also in TCPM. And around that time, possibly request a working group last call, which in principle should be held also here in LWIG and also in TCPM. So on Tuesday, I gave already a heads up in the TCPM working group session on this. So in preparation for the upcoming working group last call, we would welcome very much your comments and would appreciate very much your feedback on this. So I don't know if there may be any comments or questions.
Rahul Jadhav from Huawei. Is it working? Yeah. From Huawei Technologies. So can you please go back to slide number 6? So in case of OpenWSN, it is mentioned that the socket layer is supported. But as far as I know, OpenWSN is directly using micro IP.
Is directly using micro
IP. I mean, that is what is mentioned in the draft as well.
Yeah.
And it is not really possible to have a BSD style socket interface on whatever micro IP really provides. So I'm wondering where that information came from. And it's mentioned in red. So why is it in red?
No, it's in red because it's added now.
Added now. Okay,
Yeah.
okay. I think that information is incorrect. I believe so.
Okay, so we will double check. Thanks for that. The idea is based on the information we have, which is quite limited, actually, for OpenBSN especially. It appeared that there was that kind of support, but we can double check and maybe keep in touch with you to make sure we have the right information here.
Okay, and the draft right now, I mean, again, the second question would be, the draft right now says that OpenWSN has a direct implementation of micro IP in its stack. So my question is it really needed to then basically have the OpenWSN in this table?
Yeah,
I mean, it basically adds no value as far as I see.
Yeah, that's a good question. Yeah, maybe we can just make sure if it's just redundant, this or not. And if we can be sure that it adds nothing, then we can maybe just remove the column. Thank you.
Marco Coyo. Yes, thank you for doing this. I think this is useful work, but I think it still, in parts, it requires some work. So it needs to be, for example, it needs to be more specific with the turning off the delayed acts on backend servers, because for example, in many stacks, this is a system-wide parameter, so you turn it off for all connections.
Yeah.
And that's not advisable. In some stacks, you may be able to do per interface, but that's not enough, because you may communicate with other than IoT devices over the same interface. So you need to be more specific there. And another example is, for example, ECN. So the current text, how it describes the RTO behavior with the ECN, it's not accurate. So I intend to do a full review for that. And hopefully
Okay.
I can also provide some text for some parts of the
Well, that would be
of the
great.
document. Yeah.
Thank
And
you.
hopefully we get more reviews from the TCPM as well.
Yeah, thank you. So specifically about the delayed acknowledgement, I think we already have some notes in the lines of what you mentioned.
So it's better than earlier, but
Okay.
I believe it still needs to be more
Yeah.
specific, because some people out there might get it wrong.
Okay,
So very specific, I
Yes.
believe it should be.
so we'll definitely double check and make it sure.
Yeah.
Thank you. Yeah.
Mohit, Nohat, probably you're already doing this, but just a suggestion. I know some of you are active in different mailing lists of Contiki, Riot OS, and so on. Could you post this draft to them? I think it will make sense, and they will be happy to provide more numbers. So I guess you are active and Rahul is active in some of the forums, so it will be useful.
Thank you.
So one comment. So would you like the discussion and comments to send to both LWIG and TCPM working group, if there is any? Okay.
Possibly that would be helpful.
Post the comments and should be sent.
Yeah, so I understood that in the past, when it was decided that the home of this document would be LWIG,
Yes.
that the working group last call would be held in both working groups. So I think that is aligned with what you just mentioned. So
Okay. That's will be also helpful because for people to make decision during the working group last call.
yes,
Thank you.
Rahul Jadhav. So you described ECN today. Is any of these stacks supporting ECN or any of?
no. However, yeah, we just had some discussion a couple of hours ago. It appears that ECN might be useful. So the current situation is that no, right now it is not being used, but might be helpful. So maybe it is good to at least explain which can be the benefits, and then, well, we'll see what happens in the future.
Thank you.
Yeah.
All right.
Olaf, could you request? So we have a remote presentation from Olaf on one of the working group adopted documents that had expired, but Olaf made an update and submitted it again.
So hello and thanks for putting this to the agenda. This draft has been around for a while. So Matthias started the work around 5 years ago, and it has been adopted as a working group document 4 years ago. And then things became a bit quiet. So about a year ago or so, we tried to relive that. And the current status hasn't much changed since then. So next slide, please. We moved it to the usual working group GitHub repository, and just to give you a quick update, what were the goals of this draft? So what we started it to document the lessons that we have learned. So from implementing CoAP and libCoAP and the Erbium and Contiki, and most of this was focused on class 1 devices according to RFC 7228, and a large number of sections now deals with the message processing and the handling and certain optimizations that you can do for checking of sequence numbers and deduplication and so on. And we've also covered the core extensions, for example, observe and blockwise transfer that have been developed together with CoAP. What we didn't do was that we didn't try to start documenting any extension that you can think of and that has been evolved since then. And what we didn't do is to try to cover the special topics, for example, RC 83, 87, or the TCP handling that we have just heard about.
Excuse me, Olaf. Could
Yes?
you be louder so that everybody? I think.
Okay, sorry. Is this better now?
Yes.
Yes. Okay. Sorry. Just didn't have enough gain here. So next slide, please. So the version 6 that is now active didn't see much change. I updated the references to documents that have become RCs and checked if the text was correct, and especially added some text on CoAP over TCP that wasn't quite correct, and that where we had to add some language about the processing of the UDP header versus the TCP header for CoAP messages. And then Christian Amsus has contributed some text on the handling of blockwise transfer in presence of proxies and the specific reference to the echo request tag. In the current version of the document, there are some TBDs that need to be fixed. And there's one open issue in the tracker from Matthias where we need to just put in some text that says that URI fragments usually aren't transferred in CoAP messages, but handled locally by the client. And then there are two sections that are empty or almost empty stubs right now, which is the section about DTLS, where specifically the reference to RC 7925 should be put in there, and probably some text about the TLS and DTLS session handling with CoAP, and the security considerations if we see the need to fill that appropriately, then we should do something there. Currently, it's just an empty TBD. So next slide, please. Which is the final slide. So the big question that I have for you folks is what is currently missing and what do you think that should also go in there or even should be removed from the document as is, and then we need people to review it to move that forward. Carsten.
Yeah, Carsten Bormann. I'm a co-author on this document, so I don't have a question for Olaf. I have a question for the working group. So do people perceive a rush to get this published? Or is this something that we should be keeping working on? In the ROC working group that I chaired a couple of decades ago, we had a running document that was a bit like this, that actually was kept active for like 5 years before we decided to finally publish it, because there was always new stuff coming in, and there was never a point in time where we said, okay, we are done, because people implemented stuff and found new things. So is this the style in which we should run this, or do we believe having this document published and then start work on a second version is the right approach?
Matthias Kovac, Siemens. So I'm also a co-author on this document. a reason why I wasn't too active in the past years, let's say, is that no reviews are coming in. So I think generally what Carsten proposes is a good idea, to have something to cover all these issues that keep coming up. But I have the feeling without deadlines like working group last call and so on, we will never get those reviews.
Yeah, Mohit, Nohat. I mean, it's nice. What you suggest, Carsten, would make sense to have this document that possibly also provides guidelines on new extensions that are coming up and new things of this co-op over TCP, TLS, and how do you optimize those things. But I guess we need some editor or someone with the energy to make sure that it's in one document. So.
Carsten, again, one of the reasons why that document in ROC actually moved forward was that it was very much driven by input from interrupts. The last interrupt we had on COAP was 2014, I think. So I'm wondering whether that is maybe a reason why Matthias is right and we should go to the other mode.
I think the reason of the lack of review probably is, both important implementers of COAP has been the authors of the draft, right? I think that you should be fully responsible for the text there, and once it's done, and also the question just the custom ask should be also depends on you. I think the working group is at your disposal to either to publish it as soon as possible, or we can defer it after more input from the COAP implementers, because the COAP specification is also evolving.
Sorry, I have a comment on the previous statement. So plug tests, maybe a comment here or a pointer. So we got some inquiry from the people from F-Interop if we wouldn't revive the plug tests. So it's kind of a continuation of the former Probit EU project that actually led to the ETSI plug tests. And now it's a bit easier because it's not necessary to travel to these plug tests because they have this online infrastructure. But definitely there needs to be someone who organizes like a test week or a few days where people would at least travel in time zone to do this. And I think it would be worthwhile because some more advanced issues, let's say, came up. So something that has been discussed for way over a year is, for instance, in Californium, if you run it in a cluster mode in the backend, so you have many nodes, you have redundancy, you have failovers and so on. How do you handle observe? How to share this state, how to persist it, and so on. So there are issues that, where it makes sense to continue the document, but we also need something to get some drive into it. So let's see what others think, because we need people for that.
Yeah, so I think the authors have been the early implementers of COAP, but of course there are a lot of others now. So maybe we need to find better ways to engage them as well. Intro. Yeah.
This is Hannes. I'm wondering whether you guys, as the chairs, maybe you should organize an interop on some of the co-op features, including co-op over TCP, because that could, the feedback that you get on doing those interops could actually be fed directly back into this document. Because many of the things that we see also the OMA Bloodfest is not necessarily specification issues, but more clarifications that people want, and that document could be the destination where those recommendations go ultimately.
So we can talk to the core chairs and try to organize something.
Yeah, so the IETF is not really in the business of running interrupts. And there is this organization called F-Interop, which is an EU-funded project which is in that business. So maybe we should talk to them and find out what to do.
Hannes again, I like the guys who do the F-interop work, but I think they have slightly different goals as well, because their idea is to come up with some automated tests, which is a great thing. I'm all in for automated tests, but they have specific architecture, and you obviously then have to write all the tests to work in that specific architecture for the automated test cases, which you may or may not like. And it also has certain limitations, specifically when it comes to testing of security protocols. So it's maybe worthwhile to think about that up front. So for example, Carsten and a couple of others here have tried to do the interops for the co-op, or the testing for the co-op over TCP online, essentially. And I think that even that at that level was extremely useful as input for the specification. So I don't think it needs to go as far as really working out sort of the scripts to do things automatically in the first place.
Well, I mean, having some interrupts is better than not having any. So even if they're automated and they limit you in certain ways, I'm for it. And yes, of course, if we can have more.
Shameless plug, you can always test against test.libcoep.net, where I have the almost latest version running.
Right. So I think we need to do more of those. But one of the nice things about interrupts is that people, about real interrupts, is that people are sitting together and talking to each other. And sometimes you find out things that way that you wouldn't find out if everybody tests on their own. So maybe organizing something again, like in the Prague IETF timeframe, would be a good thing. And yeah, we would have to tell implementers approximately 6 months ahead so they can start getting travel budget and so on.
Sounds good.
Yes, very good.
Thanks, Olaf.
Thanks.
Carsten, you're up next.
Thank you. So terminology for constrained node networks. There is an RFC that was published in 2014 that actually has turned out to be extremely useful, because before we had that RFC, people didn't understand what we were trying to work on. So that was published in 2014. In 2016, 2 years minus 2 days ago, I presented the first version of a BIS document to capture more and adapted terminology. And the BIS document draft is out there. I will run through what I said 2 years ago quickly to remind you, and then I will look at one specific table that is partially new in the current revision. So, yeah, why do we want to update that thing? First, the world has moved. So some of the terms may need to be updated, but also we are defining these terms to enable conversations. So if we find out we are having conversations where there is clarity missing, then we should capture the terms that we are missing and start defining them. So that's really something. I have got a lot of really good contributions, and please keep that up. So for instance, one thing we discussed was further developing the terminology for power constraintness, or finding out good terms or clusters for network constraintness. So one constraintness we find is on the MTU side, where we have pretty radical MTUs like 8 bytes. We have millibit networks, we have asymmetry, which may be technical or may also be regulatory. And of course, we have different kinds of mobility. Not all of these things are in the current draft. So if you think it would be good in your conversations that you are having during the standards process to have good terms for these, look into the draft, whether they already, the terms in there already do it for you, or you need better ones. The probably most successful part, or the most used part of 7228 is the terminology for platforms. And, oh, that's the old version of the slides. Okay, whatever, not a big problem. We 2 years ago, we wondered whether it would be a good idea to add to the M-class machines, the microcontroller class machines, or for the trackies, the planets that look like the Earth, and add the general purpose class, which is now called J class for historical reasons. And, pardon me? Yeah, well, we have to pick a character, and if we said A class, then we would say this is all ARM terminology, so we just took a different one. And of course, ARM also has L class and R class and whatever, and so we're not doing that. So we're not consistent with ARM terminology here. We added higher classes within the M class. What we did not do is add subclasses. So for a while, people wanted to have different terms for 128.8 and 128.16 and 256.16 and so on, but maybe that's not that important. And of course, there are other things than RAM and ROM size, like crypto capabilities, protection capabilities, and so on. We don't have good terms for those yet. But I think we are seeing clusters of chips with certain capabilities in certain places here, and maybe it's worth defining terms for that. So a chip with a secure enclave or something like that, that might be something that we want to give a name. Anyway, going to the size classes, data size, code size classes. The RFC has just these 3 classes. And it looks like these are pretty much still useful. Well, you have to remember these are orders of magnitude. So there are very few chips with 10 kilobytes of RAM. There actually are some, but usually they have 16 these days. So it's an order of magnitude. So that's still class 1 and class 2 still kind of work. And there's also 1.5 in between with something like 32 kilobytes. We tried to come up with clusters for the higher capabilities. And I'm seeing a pretty clear cluster that I have called class 3 in the draft. So there are a lot of chips with that set of capability out there. And there are also quite a few chips now which are generally called luxury microcontrollers that might have a megabyte of RAM and couple megabytes of flash and so on. These are much less well defined because the luxuries that people actually need are just very different depending on their requirements. So these are interesting because while you still may not want to run Linux on these things, you might be able to run more interesting virtual machine environments on there. So you might run something like JavaScript or MicroPython on these things. Now, of course, you can run MicroPython or JavaScript on a class 2 system, but then you cannot do anything else. So it's really something that class 3 and class 4 systems are being used for. And depending on how much you want to do in these language environments, you need a class 3 or a class 4 device. So these are two trends that I have tried to put into the table. But let me just pull forward here. So class 3 is pretty recognizable, class 4 is pretty fuzzy. All these classes are essentially describing execute-in-place platforms. And that's, of course, not the only thing out there. So we have a lot of load from flash architectures, and they have quite different shape because you no longer have a clear partitioning between code and data. So you can put much more data into a load from a flash machine in many cases, but then you don't have much code. So I haven't played enough with those architectures to really be able to make a proposal here. But people who are using these architectures, please think about what your interesting classes are and whether we should be adding them to the mix here. So there seems to be kind of a standard that most load from flash microcontrollers have about 0.5 megabyte of RAM. And this 0.5 megabyte is often partitioned to various jobs. So for instance, some may actually be meant to be run as data, some may be meant to be run as code RAM, and some may be cache RAM, where actually pages are dynamically loaded from the flash. And this is pretty interesting because it has a lot of implications on the real-time nature of these things. But if you have a demand paging load from flash architecture, then of course setup code, tons of setup code no longer bother you because you can get all that stuff. And also having a giant flash available is very useful for storing long-term state. So that changes a little bit what you would be doing. So the other half here is the J group, where we have something that I call class 10 to class 19, but these are now getting a little bit on the arbitrary side. So I'm already pretty sure that these numbers here are no longer right. There are recognizable classes. So there is a class of devices that most often have MIPS CPUs that have quite limited environments, but good enough to run Linux and OpenWRT or other router operating systems. And these are really cheap. I mean, these are incredibly cheap if you look at them. So that's, and they also have pretty reasonable power requirements. So that's one interesting class that I'm seeing, and I've called that class 10 here. Then we have the Raspberry Pi class, which is, I think, pretty recognizable. We have a class that maybe is typical for smartphones these days, which would be export-controlled supercomputers in the 90s. And we have the laptop class and the server class. So maybe we can call them 13, 15, 17, and 19 and leave a little space for classes that may be coming up. So the main difference is these environments here are typically very flash-starved. So flash is really the limiting factor to what you can do with them. And they only have a few megabytes of RAM. And these classes here are all in the gigabyte plus space RAM-wise, and no longer really is useful to talk about flash size because they all have demand paging, and they are not using demand paging, but they have it at least architecturally. They usually have very large flash or SSD environments.
I think one important difference is also like you said there, they have a memory management unit, can run a generic operating system. And they typically use DDR RAM, and so there's off-chip typically.
Yes.
That obviously gives you a lot of possibilities to change the size of the RAM quite easily because it's sitting next to the chip rather than swapping out the whole chip altogether. And also, like you had before, some of the more advanced security features, like if you think, or maybe not all of them security features, but compartmentalization features, like if you think of virtualization.
Good point.
So there are definitely more capabilities suddenly there because it's the use cases are probably a little different. Yeah.
So I think issues like virtualizability are orthogonal to these. So we probably should just assign a number of names for those classes.
And it's also like, since we are focused more on the IoT use case, virtualization, in my opinion, doesn't necessarily mean like in the way that we use it on a desktop PC, but it provides another layer of protection because you can put some code in a different layer that has more privileges. So at least, so it's from a sense of security, enhanced security capabilities.
And multi-tenancy and
yeah, I'm
things like
trying
that.
to think what else could go in there. I think. So I'm in the class 10, when you say limited flash, so like some of those, they mostly have off-chip flash, so
Yes.
it's in a separate package. So, for example, if you think about the Raspberry Pi, also uses flash, namely SD card. In some of the small other architectures, like the class 2, class 3, there we are talking about on-chip flash, which makes sort of the whole setup a little bit easier.
Yeah, except for these load from flash architectures, which usually use off-chip flash.
Yeah. Yeah, I don't have much experience with those.
So basically, the reason to do load from flash is that the actual off-chip flash chips are incredibly cheap, and you don't have to load the process for creating the CPU with the complexities of creating flash cells. So in total, the cost may be low, even though you need to have two chips. So that's the reason why people are doing these load from flash things. And the other reason is that it's easier to get a couple hundred megahertz out of a load from flash. Execute in place is usually limited to something less than 100 megahertz. Okay, yeah, so what I would like to do is get lots of feedback from you, like what Hannes just did. And we want to use this terminology mainly for classes that we actually find out there in the wild. Now, of course, we know some emerging things like secure enclaves and so on, where it may not yet be possible to capture real clusters of products. So those are also fine, but things that are more established, we should actually do surveys of what we find out there and what combinations are actually in use. And also the class boundaries should be somewhat indicative of capability boundaries. And so, for instance, the only real problem, the only difference between the laptop and the server category is, do you care about power or not? And even with servers, we are starting to care about power. So maybe that is even not such a great separation. But I think it's still quite tangible in the market. So yeah, and it would be really great if for each class we had a few examples of people using the class in a specific conversation. Yeah, just yesterday somebody asked me, what is the definition of an LLN? And I said, there is no definition of an LLN, but if you mean constrained node networks, there's a definition here. And that was for a specific document, which I already have forgotten, but we should try to collect these things. So that would also be really useful input for the authors. I think that's all I have at the moment.
Are you also planning to talk a little bit about the, like we did for the DCP document on the code size requirements or RAM requirements, to then actually speak about what are the different components that we developed and how much they would actually consume? So you could make a, I think that would be tremendously useful. It doesn't, it won't be super accurate, but it give a rough idea on how much one has to actually take into account RAM and flash wise when it comes to those type of things.
This is kind of the socket document, and you're talking about a plug document. We have one of these with the crypto sensors thing. I forgot what it was named for, but that's very narrow, very specific, and maybe also not covering the whole space.
Right, it didn't.
And I think it's a good idea to start collecting something like expected burdens that specific protocols or classes of protocols or stacks are creating. And that would then fit very well with this kind of document that says, okay, there are things that only have 10 kilobytes of state, and if you need 30 kilobytes to run something, then it's probably not going to run there. But I don't think that should be done here.
Okay, I see.
In the US lawmaking, for each law you make, there is a mandatory piece, which is you have to survey the paperwork requirements. How much paperwork does this add to the life of a citizen? And maybe we should do something similar, not call it paperwork requirements, for protocols. So we are only standardizing it if we know what kind of burden it puts on devices that use it.
Thanks, Carsten. Daniel, you're up next.
Hi. So, minimal ESP. Does it work? Okay. So the motivation to have a description of the minimal ESP is clearly that kernel implementation of ESP fits multi-purpose usage of OS and include a lot of options. The inclusion of all these options is performed at the expense of resource and in some cases a lack of performance. And with constrained device, they are likely to only consider a subset of these options and then to end up with a very optimized ESP implementation adapted to one specific usage. So with the adoption of IPsec by a lot of IoT device and the minimal IGV2 or ESP header compression, it becomes crucial for ESP implementation to be designed to be able to interoperate with the constraint device, and also for this constraint device to interoperate with the standard ESP. So the main motivation is to enable interoperability between a minimal implementation of ESP with the standard implementation of ESP. So the scope of the document is to provide a minimum set of properties that an ESP implementation needs to meet to provide such interoperability. So the document provides guidance on implementation and implementation experiences. The goal is clearly to remain fully compatible with the standard IPsec ESP, and So we provide recommendation on how to build all the ISP, all IPsec ESP fields, as well as some recommendation on which crypto suite should be used. So here is the IPsec ESP packet. That's the standard one. And so we review all the different parameters and define how they can be implemented. So for example, the SPI, we defined how we can reuse a predefined number, because it doesn't necessarily need to be a random one. Sequence number, we defined that, okay, you can have an incrementation, but you could also use it at time, because it's only an incrementing function. We also had some various discussion about the padding, how to address the header, IPv4 and IPv6 alignment, how it could be part of the encryption, so depending on the size block, and so on. Yeah, we describe various ways to implement it so that, well, to reduce the overhead. Next header, well, not much to say about this field. So the document has been reviewed and will continue to be reviewed by the IPsec ME working group. It's already, well, we already had significant review and presentation, so it's already in a good shape to reach the LWIG milestone, which is for November. It's aligned to adapt IPsec to constraint devices in IPsec ME, and as well as in this working group where we had the minimal IV2. We have an internal implementation in C. We know also that some of the Riot folks are implementing it or trying to. And we would like this document to be adopted as a working group, go through a bunch of revisions, but I think it's rather a small step for now. So thank you.
So this is in our charter, and I think this document has been presented for a while. And let me first ask, how many of you have read this document? If you have read it, please raise your hand. So, okay. Go ahead. Or any version of it. More like 10, right? Okay, roughly 10. So if you support the adoption of this document as a working group document, please hum. If you are against of adopting this document as a working group document, please hum. Okay, that's clear.
Will confirm on the list.
Yeah,
Rene, I guess you are up next.
I actually have a question about this document. Can I still ask the question?
Yeah, sure.
I have not yet read it, but I was just wondering whether you fixed the algorithm options, or is it changeable?
So is the question if we recommend one specific algorithm?
Yes.
No, we describe how to select the algorithms, and the recommended algorithm I described in another document, which is the recommended suite for ESP. And this, because these crypto algorithms are likely to evolve over time, but some of the considerations on how to choose them remains the same.
Great. Okay, so I presented this a precursor of these slides in March in London, I think. So what is this document about? It was supposed to be very brief, and if you look at the main content, it's like 1 page, but there's like currently, I think, 16 pages of appendices. So what's the crust? The crust is that IETF uses various elliptic curves, the well-known NIST curves, and also curves that have been endorsed by CFRG, and they seem to be entirely different beasts. So the draft actually describes how to morph the representation of the CFRG curves in a shape that can reuse the existing, for example, hardware implementation of NIST-like implementations, thereby allowing essentially 2 implementations for the price of 1. And I also think it can be used if people want to design another, let's say, key agreement scheme using curve 25519 or what have you, to describe it using existing standards, because you can just transfer whatever you cook up into things that get cross-referenced, for example, NIST SP 1856A. So what is new in version 1, which actually is now version 2 since about 1:45 last night. So in March, I had the draft that allowed you to pick an existing implementation for ECC using, for example, NIST curves. Just plug in parameters for, let's say, curve 25519, and you're done. But some existing implementations, actually, they hard-code some parameters, so they're slightly less generic than maybe one would wish for. So now in a new draft, I actually accommodated that. So if you have something that does something that's known to cryptographers and probably not too many people in this room, called using Jacobian coordinate implementation using some particular fancy parameter a equals -3, then you can still grab that existing implementation, use your CFRG curves, and run with it without having to redo work, provided, of course, the implementation is secure. So I provided that one, and as another bonus for people who don't have to deal with that constraint, I also optimized one of these mappings so that you could still get basically something called 1 multiply for free per bit of your scalar of the elliptic curve. So this may all sound like very detailed, but essentially the draft only describes mappings that are public operations, essentially to whip the CFRG curves into a shape that's known for people who have been working with NIST curves the last 20 years. Then lastly, Mark, it's being implemented right now, or it will be implemented in the next few months by one of the people in, I think, Karsten's group. And so I'll have some more conversation. If he runs into a roadblock, then maybe I have to write another paragraph of how to do model reduction using something called Barrett reduction or Montgomery reduction. And then I will just add it to the draft. So next step, the question is, of course, like, why am I standing here? The question is whether this would be useful for this audience. And if so, should we make this a draft? So it just has been gathering dust on my machine, so we could either do something with it or I could move on to something else. And the other question I had as a side is, are there any other kind of like implementation mysteries of ECC that could benefit from some kind of write-up? Okay, I'm done.
Carsten Bormann, I'm sure the answer to your last question is yes. And I generally like this work because it's really hard to do crypto agility on a very small device. And if we find ways to build several different algorithms based on the same infrastructure, that really aids crypto agility. So I think this can really be used to increase the security that we are getting, and also to increase the interoperability between different ecosystems who may be making choices that require different things. So I think I really like this work, and that's why I immediately started looking for a student who was interested in this. And,
poor guy, he doesn't know what he's getting into, right?
Is he listening? No, you can say that, okay.
Hi, my name is Sean Turner. I'm not a cryptographer. And I also didn't make this session in London, so if you talked about this there, just tell me to sit down. One of the more interesting sections in this draft is section 5, which is the shortest draft, which says, if you do this, you might need some new identifiers, right? So there is a working group in the security area called Curdle, which is looking at curves and deprecating some things and adding some new ones. And they're supposed to be the people that are adding into PKICs and certs and all the other places. So I'm curious if it might be better targeted there. That's just kind of a meta discussion question that you guys will have to think about. And the other one is this is primarily because it's just math, right? You can just kind of change some things. It's all over here. You do some transformations, but it really gets down to the identifiers that you're using in the protocols, right? So that the chip that's already got the NIST stuff built in can do the transformations to just use the code that's already there, right?
Yeah, so I indeed mentioned in the draft that you could have another identifier and essentially have a kind of a Weierstrass version of the CFRG curves.
Right.
But you could also just, as an implementer, you could just live with whatever curve 25519 representation,
right,
and do a very thin kind of conversion layer but internally, and then you don't have to deal with any YANA, whatever politics.
Yeah, registrations. But it's still, I mean, these are supposed to be small devices that are specialized, that have code already built in, and the shim layer seems like something new. How is it buying you anything then? That's what I'm trying to figure out. Like, what's the driving desire to suddenly do these things? Is it because the things that you're transferring are smaller? It's going to speed the code up. You're going to have less memory usage, or is this because we could do it in the future and we might have a key management technique that we want to use that isn't yet defined? Do you understand my point? I'm trying to figure out what's the driving motivation for this. If you've already got like code that runs in a chip, and there's going to be some shim layer that you're going to be running on your CPU, it seems like.
Well, I think if you have a small device and you want to, let's say for whatever reason, you implement the NIST P256 curve, right?
Right.
And ECDSA. And you also implement curve 25519 and the ED 25519 signature scheme.
On these small IoT devices, right? I mean, you see where I'm going, right? Like, it can do this, it can do a whole bunch of other things. Like,
yeah,
what are we optimizing?
Somewhere in the ecosystem, you will have devices that speak both.
Yeah, fair enough. Yeah.
So the actually discussion was triggered by something in another group,
right?
In the 6low space,
okay,
where people they had various options of doing things, and not all devices may speak 2 languages, but some will, and they can save.
Fair enough.
I think actually some of the whole appendix should have been written by a CFRG like 3 years ago, but they never did. So that's why.
Fair enough. Okay. All right. Cool. Well, thanks. I'm just curious.
Yeah, just to give a very real example. So you might run into an environment where you want to use 25519 for your main crypto work, but you also occasionally have to handle certificates that happen to use P256. So you have to have both implementations, and then something like this is really useful.
Right.
Mohit, no hack. So I think we started discussing this with Rene in 6low context. In the context of secure neighbor discovery, we were coming up with some protocol discussing crypto agility, and that's when we started discussing this. And he told me that you can use the same implementation to actually support both curves. And I was like, okay, I didn't know you could do that. So that would be interesting. I think there's still some protocols that mandate P256, and most of the new ones mandate 25519. So if I want to support more than one protocol, I might run into this problem, and I don't want to duplicate the code. So at least that was my motivation of this work. So is there someone who objects to adopting this as a working group document, knowing that we might have to send this draft to CFRG, to Curdle for reviews later on? If needed, we can do a last call on with other groups as well. We have the Curdle chair in the room, so that's a good thing.
I'm fine. So Daniel Migo Erickson and the co-chair of Kernel. I'm fine. You asked for a review at Kernel. I think that's a great thing. You should do that really fast because we're about to. The working group is not very active currently, so it gives its time to review that. But don't wait too long.
So do you suggest for me as being ignorant here, like what is the output of kernel? Like,
they're looking at deprecating or providing some EC curves to various algorithms.
Mm-hmm.
So you can, it's probably the right community that could provide some of the feedbacks. So you can just ask feedback.
But if there would be no YANA number required,
but so I don't think this is gonna be hosted by kernel.
No, it's just for review from the community and
just for the review.
Yeah.
So just CC.
But
as long as politics doesn't take over, it was supposed to be like a kind of community service at the end of October.
Right.
So,
yeah. So we can do a hum. Who would want this to be adopted as a working group document? Please hum now. Who is against adopting this as a working group document? Please hum now. We'll confirm on the list.
Thank you.
Francesca, our last presentation for today.
Last presentation for the last session. We made it. Hi, everybody. I'm Francesca. I'm presenting the update to the protocol comparison draft, which was adopted between last meeting and this meeting. It's a very quick presentation. So the update, so in the next version, we have just fixed some editorials and typos. Nothing major has happened. And so right now the draft is updated according to version 26 of DTLS 1.3 and the latest version of OSCORE, which is version 13. So the next steps are to update according to the latest version of DTLS 1.3, which right now is 28, but it's probably going to be 29 or later for next face-to-face, and also to answer the review comments we got. Thank you for those. So we got two comments sent directly to the authors. Maybe have more reviews, but that's the status of the draft.
Well, please review. I will do my chair's review before the next IETF, but this is a call for group members to review the document.
Thank you.
All right, we are done for today. Thank you for joining.
Thank you. Thank you. Yeah. It's Friday afternoon.